So when dilating, using a scale factor that is bigger than 1, it's going to enlarge. So what we're saying here is if I'm going to start with the point A comma B, and I'm going to dilate that point around the origin or about the origin, all I have to do is take my scale factor, multiply it by the x-coordinate, take my scale factor, multiply it by the y-coordinate. That's all you have to do. Okay? If my scale factor was like 1/2, and I had the point A comma B, then that coordinate's going to be 1/2 of whatever A was, and that coordinate's going to be 1/2 of whatever B was. So this would be an enlargement, which is usually the word they use, but that's growing, right? Okay. And this one will be called a reduction, which we usually call shrinking. Okay, but those are the mathematical terms, enlargement and reduction. Is that okay? All right, so when it says dilate the figure here by a scale factor of 3 about the origin, all we have to do is figure out what are the ordered pairs. So I'm just call this A, call that B, call that C. And I know you guys have the paper in front of you if you print these off, which is nice. But I don't want to go through here. I'm going to use Geogebra here in a moment because there's some things that relationship-wise are going to be important. But if A is located at, what, 3, 2? B is located at 1, -1. And C is located at -3, 1. Okay, if I want to find A prime, all I have to do is take my scale factor and multiply it by those two things right there. So give me 9, 6. Does that make sense? Okay. B prime is going to be 3, -3. And C prime is going to be -9, +3. Is that all right with everybody? So what I want to do is just real quick on Geogebra is demonstrate those points. So A equals 3, 2. B equals 1, -1. C All right, so just placing those there, okay? I'm going to connect them with the polygon tool. So there's my triangle that we started the problem off with, right? And there's the dilated triangle, okay? Let's see here, let's change the color of it. All right, so we started with the blue triangle, okay? We dilated it, and it gave us the red triangle. Now, the way that a dilation works here is just think about this. If I wanted to go from 0, 0 to A, okay, so let me put 0, 0 in here real quick. Here's point D. You need to go 3 to the right and 2 up, right? Okay. Well, our scale factor was 3, so let's use that idea of translations maybe to get and see how we go from here to there. If I go to the right 3 and then up 2, so I went right 3 and up 2 one time, right? Let's go right 3, up 2 one more time. It gives me where my cursor is, right? Let's go right 3 and up 2 a third time, and it gets me to A prime, right? So that 3 movements of right 3 up 2 that 3 is the scale factor. Does that make sense? So if my scale factor was 4, I'd go 3, 1 more, and up 2 more, and put A prime there. Does that make sense? So it shows me how we end up enlarging that point there to that one. Okay? And we do the same thing for B. So if I go from D to B, it's right 1, down 1. So then go right 1, down 1 more, and then so right 1, down 1, right 1, down 1, right 1, down 1 gets me to B prime. Okay? In this logic here, what that does is it tells me that if I were to take a point D as my point of dilation, and I go through a vertex or a point that just any point really that I want to dilate, the dilation has to end up being on that ray. Does that make sense? So A prime, if I didn't know where A prime was, if I did not know that point right there, I would know at least that it's on that ray somewhere. Does that make sense, everybody? Okay. And that the reason for that is, it's the idea that we went over 3, up 2, over 3, up 2, over 3, up 2. We created that line, right? Okay, we have a slope there of up 3 over 2, or right 3 over 2, up 2. So if for whatever reason maybe I want to I'll delete all this stuff. I'm gonna hide it, and we'll be done after this. Let's say I gave you dilate that from A All right, so let's say I gave you this image here, okay? If I use a scale factor of 1 as my dilation, it just gets me my image and my pre-image are the same thing, right? I'm going to take this and make it grow, okay? So you can see that dilation, right? Does that make sense? Okay, now my question is, what point am I dilating on, okay, or about? Maybe if I go and I can move this, let's move it to there, because I think where I had it, maybe it looked like I was dilating around the origin. Okay? So here's my question. If I take this point, let's put point D right there at negative 2, 8. Negative 2, 8 is point D. So then D prime is at negative 4, 20. Is there a number, okay, what would I multiply negative 2 by to get negative 14? 7, right? So you might think, hey, my scale factor is 7. If I multiply 8 by 20, 8 by 7, do I get 20? No. So my scale factor is not 7 because it needs to be constant between the x coordinates and the y coordinates. So the question is, well, what is your scale factor? Maybe what is your dilation point? Okay. And because that scale factor was not 7, it tells me that the dilation point is not 0, 0 here. So if I want to find the dilation point, what we do is we're going to start at the point of our dilated image, okay? Start at a vertex, and we'll go straight back to its corresponding point there. Does that make sense? And what that tells me then is that somewhere on that line is the point that we used as our point of dilation. But there's an infinite number of points on that line, right? So how do I really how can I zero in on that point? Can I do it again? And then do it again with B prime to B. And where do all 3 of those lines, I'll do it this way, make it look a little bit more. Where do all 3 of those lines intersect, no matter what my shape is? They're intersecting right there, correct? That is the point that I used for my dilation, okay? It's point A, and if I ask this to show point A again, is it right there, okay? What I like about this is the idea. You remember when we talked about there was a question about a giraffe that was on a film reel and a light showed through it and projected on a screen. That's exactly what we've got going on here. Here's the light, here's the film, and we project it to something bigger, right? So sometimes a dilation is called a projection, or we project onto another image. Okay, so we don't always have to dilate around 0, 0. But if you do, all you do is you multiply the ordered pairs. Is that something we can do? Yes. Okay. So what happens then? Now, if we know that this point here, so let me just to make this a little bit easier, let's put some nice values, nice ordered pairs here for that. So right now, we're seeing this point here is 4, 2. Okay. What happens is, and I'll talk about this in more detail tomorrow, in order to find the dilation factor then, the scale factor that we use to multiply D's ordered pair to get D prime's ordered pair, it is the ratio. I don't want to say it that way. It's the idea that if I took point A and moved it down 2 and left 4, and then moved all of these down 2 and left 4, everything would still be positioned relative to one another the same way. Does that make sense? So I'm going to move this one down 4, or down 2, left 4. And then I'll move this one down 2 and left 4. Is that 4? Hope it was. We'll go back. Down 2, 1, 2, and then 1, 2, 3, 4. Okay. So now I can look at the points A prime, B prime, and C prime compared to A, B, and C, or I guess it's B, C, and D, and B prime, C prime, and D prime. Let's look at those. If I look at those two, okay, what do I multiply 14 by to get 42? 3, right? What do I multiply 0 by to get 0? Could I use 3? Okay, so that one's, maybe that's not the best one to look at. If I multiply those two, if I take negative 8, multiply by negative, to get to negative 24, do I get 3? 2 times 3, does that give me 6? And then look at those two. Multiply that one by 3, I get negative 24. Multiply that one by 3, I get 24. So what we have to do, and that shape right there, is exactly the same as it is when I moved it, or when I started with it being right there. Okay, so that's kind of what we'll do. Is I like to think about, we have the triangles positioned right there, and the point A as my point of dilation right there. And I like to view the grid or the coordinate system as a transparency. You guys know what transparency is? Like a plastic sheet of paper with my grid lines on it. And basically what I'm going to do is I'm going to shift my origin to point A, and then see where did all the points A or B prime, C prime, D prime, and B, C, and D, where did they go, and then make the relationship between those. Does that make sense? So I'll show you how we do that tomorrow without having transparency papers. But that's the logic of doing it around a point that is not the origin. You're not going to see any homework questions tonight. That did all your homework. I'm not going to add any homework tonight anyways. Okay, so the assignment that is open from yesterday is all you've got to work on. So I'll let you go and work on that. Sorry, I went a little bit longer. Hannah, did you have a question? You got it figured out? Good deal. If you guys have any questions about anything, let me know. You can use the restroom. Plug it in. Did it? That's okay. Thank you.